In 1980, a study was begun to demonstrate that aircraft can efficiently and economically apply insecticides to conifer seed orchards in the southeast. These trees are grafted from genetically superior trees. The seeds they produce may be valued at $500 per pound. Insects can wipe out a cone crop if not controlled. Ground sprayers now apply insecticides. The large fan directs air at high velocity past an array of spray nozzles. The resulting mist is directed toward the upper crown. But problems exist. Tall trees are difficult to spray adequately. Several days are needed to spray an entire orchard, often too long to prevent insect damage. In the western mountains, both fixed-wing and helicopters have been used successfully to apply insecticides. The orchard was sprayed with dyed water. Spray deposit cards on the ground and in trees compared deposition and coverage. The red dye was added to form visible droplets on the cards. One objective was to determine if the aircraft wake is useful to deliver the spray into the canopy and if the wake behavior is predictable. Computer models are available to estimate spray behavior over row crops. This model shows wake behavior over a flat surface. But little is known about the interaction of the wake over tree canopies. To better understand the relationship between the wake and tree canopy, colored smoke was used to show wake movement. A tower was placed among the trees and remotely activated smoke dispensers were mounted on the tower. Aircraft were flown directly over the tower. Meteorological conditions were monitored at ground level and up to 300 feet with a tethered balloon. The balloon supports a small instrument package that measures temperature, relative humidity, wind speed, wind direction, and altitude. This information is continuously transmitted by radio to a ground recording station. Two aircraft were selected, a Stearman biplane and a Hughes 500C helicopter. Each aircraft was rented with the spray equipment normally used by the operator. The Stearman was flown at 3 different speeds. This test is flown at 120 miles per hour, and the predicted vertical speed of the wake is 3 miles per hour. This test is flown at 90 miles per hour, and the predicted vertical speed of the wake is 4 miles per hour. This test is flown at 65 miles per hour, and the predicted vertical speed of the wake is 6 miles per hour. The test speeds selected for the helicopter were different than the fixed-wing speeds. The objective was to evaluate each aircraft over its normal operational range of speeds. This test is flown at 75 miles per hour, and the predicted vertical speed of the wake is 3 miles per hour. This test is flown at 50 miles per hour, and the predicted vertical speed of the wake is 4 miles per hour. This test is flown at 25 miles per hour, and the predicted vertical speed of the wake is 8 miles per hour. This test is flown at 15 miles per hour, and the predicted vertical speed of the wake is 15 miles per hour. Computer models are being developed that describe the interaction of the wake and spray droplets. This simulation shows the interaction at 2 speeds. These models are being modified to incorporate the tree canopy into the wake-droplet interaction. The aircraft wake is a useful tool to deliver spray to conifer orchard trees, and in the future, its behavior will be predictable.